So, okay, I hope you understand what we're doing with the predictions over here. So, how we're going to be forecasting, how we'll be going to the 18 values. So, if you remember, back when we set our testing data, we set our testing data to be the last few years. So, last one and a half, okay, last 1.5 years. So, which was this, and our training data ends here, right? So, if we want to forecast, if we want to get into this side of the thing, we have to start from the last 12 months over here, right? So, if we predict on this 12 months, it will give us the first value of this test set, right? So, if we were to predict on the, let's say, where will we divide it? Yeah. If we predict it on the last 12 months of the training set, if this is the training set right here, if we make a prediction on the last 12 months of the training set, it will give me a prediction that would be equal to the first month of our testing set. So we will keep storing these predicted data, and then even we take this guy into our batch as well. That would mean that it will have 11 months of our training set, and then one would be the predicted value. And then if you run our model on that, it will give us the next one, which would be the second month of the testing set. So when we keep doing that, eventually we will get 18 values, and we will store them all into a array. So the code for this is a little, you can say, confusing to look at first. So I'll try to break it down as much as I can. So, I mean, of course, once you look at the notebook and try to do it yourself, you will understand it much better. So test predictions is the thing that I'm going to be adding all my predictions in the 18 months that we have set out for testing. So that's what I'll be predicting and adding it into the test predictions. So the first evaluation batch. So the first evaluation batch, like I said, has to be the last set of data in your training set. So we have taken the length to be 12, right? So we want the last 12 months of our data to be the first batch. So the first eval batch is the last 12 months of our scale trade data. And then we will get a current batch from it. So we have to reshape it because it takes in a specific shape for our input of our, what do you call it? The input, the model takes in a specific input, like we specified the input shape, right? So that's why we have to reshape it according to that. Uh, if you like do some print statements here and there, once you're playing around with it, you can see that it actually makes sense that why the input shape is like that. So okay, so the current batch we set it to be the first evaluation batch dot reshape. So we'll reshape into the shape that our model will take in, and now we will start our predictions. Okay, so how many do we need? Right, we need 18 months because that's how many we have set as testing. So that's what we do for I in range length of test. That means for I in range 18. So we will be doing this 18 times. And then we'll be doing a prediction, which will be current pred, which will be model.predict on our current batch. Okay, and we'll be taking the first value of that because there is a little bit more. So 0 is for grabbing just the number, and it also has like some stuff appended at the end of it. So we don't want that. We just want the number attached to it. So yeah, that's why we do the 0 over there, and we store it in current pred, and then we append that current pred value into a test predictions array. And now this is the code which I said is a bit difficult to understand because it uses some complex array splicing and all that. So what we're doing in this is that this part of the step. So that means that adding this into this and removing this first element out of this batch. So we take our current batch and set it to be np.append, which means whatever the two things are in here will be appended one after the another. So current batch will be appended with current thread. So current thread will be at the end of the current batch. But over here we've done some splicing to get rid of the first element of the current batch. So our shape of the batch is 1 comma length comma features. So length is in the second one. So we get rid of the first one in that. Right, so we get rid of the first one. That means we get rid of the 0th element, and we start from the first one. We splice it like that so that we get rid of the first element of that. And now we append the second one. We append the current prediction into this. So now our current batch includes the last 11 months of our training set, plus the predicted value based on the last 12 months. So now in the next loop, once we go through this, our after doing this, after going through this step, this will now contain 10 months of our training set. And then the two predictions, the first prediction is this one, which we got in the previous step, and the next will be the next step, which we got. So that would be the next prediction that would be appended into it. So after a while, after I think 12 iterations, all 12 of our batch would be consisting of prediction data only, and the rest next six would be based on the prediction data only. So so that means there will be no trace of the training data anymore. So now that we have our 18 predictions in our test predictions, I should have actually done a print statement to show them, but okay, whatever. You guys understand it, right? So we have appended them on the current print we appended into test predictions, and we've done that 18 times. We took all the 18 predictions and we have them in a array. So over here we have, so now are we good to go ahead and just like plot this out and compare it with our original test data? No, because this is the scaled data and we need to revert the scaling in this. So I create a new array and set it to be the inverse transform using the scalar. So this scalar is the same scalar that we used at the start to scale these values in the first place. So we have to use the same scalar to inversely scale these back into the original values, like what could be the original values. So now what I'll be doing is now going back to the test data set. So test data frame, which was this at the very start. Now what I'll be doing is now I'll be appending my predicted values on the right side over here, like not the right side. By that I mean I'll be appending my predicted values as a column over here. So our predicted values will be right beside this, so that we don't have to create like a separate data frame with these date indexes and all that. So I will be teaching you how to do that. Don't worry. So yeah. So now doing using this simple pandas code, we can make a new column in the test data set called predictions, and we can assign it to be the true predictions array which we have over here. And ignore these warnings. This basically means that you are trying to create a you whatever changes you're trying to do will actually affect the test data set. So are you sure, if you sure you want to do it, it's you just ignore it. Okay. So now you have this test data frame that you have, and in this it has the sales and it's the predictions for the dates that you have selected as testing data. So now moment of truth. Now we'll be trying to see how good our model did in predicting these 18 months into the future. So now let's plot these two. Now let's plot this entire data frame and let's see how it comes out. So over here, the blue line, as you can see, is the sales data. That is the actual original testing set that we set out at the start. And the orange line over here is the values that we have predicted using the model. So it's not a perfect fit, but I feel like this is actually pretty impressive considering that, I mean, it basically forecasted into the future. And even though it's not perfectly fit, it is actually it picked up the trend which we discussed, like that spike in December and all that. So I feel like our model did pretty well. So now there is a way to upgrade this. Okay, we've used your RNN and all that we've used our RNN model, RNN layer to do these predictions. Now there is a way to upgrade this, and that is by fixing the errors, or we can say the drawbacks that our RNN layer has. So let's see what drawback am I talking about with the help of an example. So a quick question for you guys, you have to fill in the blank. Okay, go ahead. Let me know in the chat what the blank could have. I'm waiting, by the way. Yeah, I won't go ahead. Fill in the blank and let me know what could be. I was in Belgium. Over there, I learned to speak dash. So fill in that dash. I mean, don't no need to Google. Just do what you think. Uh, okay, okay. That's okay. Yeah, we have a Google person. Yeah, he Googled the answer. Okay, so okay, all of you have seen the Google the answer. But yes, so what was the thing? Okay, so okay, a lot of you are right. Okay, so the people who said We got a very interesting one. One of you said politely. Okay, that's also a valid answer. But most of you guys, Belgian. Yeah, so most of you guys answered it to be the language spoken in Belgium. So there's like majorly three. There's Dutch, German, French, I think. There's not Belgian, if anybody thought Belgian. Okay, if there's not Belgian, though Belgian chocolate is amazing, it's not. Belgian is not the language. So Dutch, French, and German would have been the right answer. But okay, that's not the point I am. That's not the point I'm trying to prove. What I'm meant to say is that how did you know? How did you know that you have to? Who are the all the people who search the answer? How did you know what you had to search? Like you search something like the language spoken in Belgium, right? Like something like that. So how did you know to search that? That's because you read this word Belgium. So now this word Belgium has defined the entire context of the sentence. So the entire prediction, this Dutch is based on this word. But if you look at it, this word is so far back into the sentence that if we look at our RNN model, how our RNN model works is that it takes in the output from the previous step, passes it into itself in the next step. So as we go ahead, as we put in more inputs, you can think of it like the word which came as the first step would lose a lot of its weight as we get towards the last step. So this Belgium is like the fourth word in this, and we're predicting at 4, 5, 6, 7, 8, 9, 10. 10 after the 10th step. So the Belgian was more than halfway back, halfway behind the stuff. So it has lost a lot of the weight that it should carry. So if we were to just use an RNN, basic RNN to do this prediction, what it would do is that it would not give much weightage to Belgium and would just predict it based on whatever. So it would realize that it could be a language because we've given it speak, right? It could realize that it's a language, but it would not be able to figure out that it was a Belgium for language of Belgium because it was so far back. So that's the reason. So our RNN model, you can think of it as having a very short-term memory. Like the short-term memory that we have is really very short, so that we can't actually, keep the weightage of the words that matter. So the way we fix it is by so we need like a longer short-term memory, right? Like our short-term memory right now is not big enough to actually predict this properly. So we need a longer short-term memory. uh, Wait a second.
Varun, maybe once you quickly complete your part, we can
Yeah,
have our break for 10 minutes.
yeah, sure, I'm almost done. I just have to show them the LSTM and then I'll
Okay.
pretty much wrap it up. So, okay. So we need a longer short-term memory. And to do that, we use something called the LSTM, which literally means which literally the full form of it is long short-term memory. Like they were like, okay, we need a longer short-term memory. Okay, why don't we use this? Okay, what should we name it? Just name it long short-term memory. Like, they are very creative, I know. So another problem, so I know this looks very complicated, and I mean, I would have loved to explain it, but this goes beyond the scope of this session, as well as when it comes to the amount of brains you guys can use for this, as well as the time we have. So we won't be covering this in detail. Just know that this is a better version of RNN. Okay, so now by we're using this newly found knowledge of LSTM, let's quickly update our model to use LSTM instead of RNN. So over here, instead of having the RNN layer, we have chosen the LSTM layer, and we will do our predictions based on that. And now we plot the graph. You can see over here, I've added it to the same data frame as before. So over here, you can see that the green line is the LSTM line. And the fact that you can't even see the green line over here says a lot in itself. That means it's overlapping with the blue line. I know over here it's not as good, but over here it perfectly figured out the spike. So Even if it's not like perfect, it's not worse than your basic RNN. It's better than your RNN. So that's what my point was, that LSTM is better and in multiple ways. So also it, like did I mention vanishing and exploding gradients? It also tackles that problem, but we don't have enough time to cover that. So finally, let's try to train our data on the entire data set. And now we will, like, instead of having the training and testing split, we will be training it on our entire data set. And that's what we have done here basically. And the generator would be the same. The only difference would be it will be for the entire data set. And once we fit it, we have trained it for 80 passes. That's what I felt like was a good place to stop. And also you can decide it based on the early stopping, where the early stopping stopped last time. You can basically try to play around that value till you get the lowest. So over here I got 0.11, which is 0.0011, which is pretty low. So and then based on this model, we'll be forecasting the same way we did over there, but instead for 18 months, because we don't want to test anything. We have no testing data, right? So we want to just see how well it did, how it did. So we'll quickly just look at the forecast, and that would, and we just pass in the how much we want. So that is 12 months. So that's how big our loop would be. We append it in this forecast array, and then we will be creating a new data frame. So, and the timestamps, and with the timestamps, we will have to create ourselves. So this is how we create them. I'm not going to go too into detail as to how exactly this works, but basically we want the data for after October 2019, because that's where our data ended. So we go all the way from November 2019 till whenever we want. So the period, that is the 12 months. So now we created a new data frame with our forecasted values. Now we plot both of these. So this was our original data and this is the predicted data which we have forecasted. So now let's merge these two plots. And over here you can see this orange line is the one that we have predicted. So let's zoom on that a bit. And over here you can see that it predicted the trend very well. I mean, I should be happy with it. And this is the reason that there's a gap here, is because there is no line connecting these 2 points. These are two separate points. Just like these are the two separate points, similarly, these two are also separate points. There's just no line connecting them because they're on different data frames. So our model was able to pretty well pick up the trend on what we were trying to give it, and it did a pretty well prediction. But now here's the place where the, you know, how good actually is your model comes in. So now if you remember, this has data only till 2019, but in the site we have data all the way till 2020, like including the 2020 data. So over here it predicted that yeah, it's normal, it's all cool, it's increasing, that the spike is still there and all that. But if you look at the actual thing that happened in 2020, right here, you can see that the sales dropped to literally 2,904, which is, I mean, which is not being predicted by a model. And the reason for that is the entire reason why this event is being held online, and which is a testament to how reliable actually can your machine learning models be. So this is obviously because of COVID. The COVID really hit the sales for everything really, and you can see here clearly how bad it is. Whereas our model is like, hey, it's all good, it's perfect. April sales are doing very great. Whereas actually it's really not. So that's just a way of saying how unreliable your models can be. So I think that's all I can give from my side towards teaching you guys RNN as, and also a little bit of LSTM. I highly encourage you guys to check out what LSTMs are and go a bit deeper into how they work. And yeah, I think that's it.